But if I go and waste time on the tough one and there are simple one ahead, I don't take them. It's not worth it. Is that okay? So this one is simple.
Yes, sir.
It's okay. So let's do it. We have the kinetics. Yeah, can you read, please?
Reaction kinetics. Rate of reaction. Rate of reaction is expressed as change in concentration of reactants or products per unit time. Rate of reaction measures the speed at which a chemical reaction occurs.
Rate is what? Change in what?
Concentration over
Over
time.
time. And unit is what?
Mole per dm cubed.
Do you understand I got the unit?
Yes.
Concentration
Concentration is
is
over
mole per
dm cubed
dm
over
cube.
20 seconds.
This one is time, seconds. So it's set to 6. So I'm done with rate. Then you have to define it. I've defined that. Next one. Then you define, you understand what
Frequency.
frequency of collision. Can you read?
It is the number of collisions which are taking place per unit time per unit volume of the reaction mixture. It also means the average rate at which two reacting species undergo collision in a given system. Not all collisions lead to chemical reaction.
You have learned that in GCSE, if you don't have up to the required activation energy, you are
Mm,
wasting your time. Collide from now till the what and you will not react. So not all collision will produce chemical reaction. Some collision don't produce chemical reaction. Is that okay? You are gone.
yes.
What do you mean by effective collision? You are gone.
An effective collision is one in which molecules collide with sufficient energy and proper orientation so that a chemical reaction occurs.
Though
Effective
In Cambridge, they don't really emphasize this. Though it's there, but they
proper
emphasize
orientation.
sufficient energy. So this is what they emphasize in Cambridge. They don't really deal with they don't really emphasize that. The emphasis is that they must talk about sufficient energy for them. But this is the standard way of defining it. Yeah, go
Mm.
on.
Effective collisions are successful collisions that result in a chemical reaction, breaking bonds in the reactants and forming products.
Yeah. Yes, yeah, what is a non-effective collision? Yeah, go on.
A
Cambridge calls it
non-effective
non-effective. They can also be called ineffective. The same thing. Yeah,
mm,
go on.
okay. A non-effective collision is one that does not result in product formation. Reactants which do not possess the minimum required energy, activation energy, will undergo non-effective collisions.
So you get that? They will not react. Is that okay? They will not react.
Mm,
Is that okay?
yes.
Next one. What is activation? Now, this topic is very simple. We'll finish on that note and then we'll go to another one. What is activation energy? Yeah.
This is the minimum energy required for collisions to be effective. It is the minimum energy the reacting particles must possess for a reaction to occur.
Yeah.
Activation energy is the energy barrier that must be overcome for reactants to be converted to products.
I only gave three definitions. They are all the same thing. Is that okay? Good.
Uh-huh.
I'm sure you understand that. Let's do
Yes.
classwork. No, yeah, let's do classwork. Yeah.
A
Can you read?
chemist A chemist added 3.25 grams of zinc to 250 cubic centimeters of 0.5 mole per dm cubed hydrochloric acid under certain conditions. The time taken for the reaction to be completed was 3 minutes and 20 seconds. How how
How
did the
did
chemist know that the reaction was completed? A.
yeah. Go and see the equation. What's the equation? The equation is what? The equation will be what? There is zinc and HCl. Zinc plus HCl to what? Zinc chloride plus H2 gas. How do you know the reaction is completed? From the
Uh,
equation. How will you know?
he stopped observing the hydrogen bubbles in the
Thank you.
reaction.
Bubble stop. Simple.
Mhm.
You cannot say the solid stop dissolving. You know why? They didn't tell you the one that is in excess here. If they have told you that, okay, oh, zinc was in excess, you now think that, oh, the solid stops dissolving. That's one observation. Or bubbles production stops. Is that okay? But here, the
Yes.
bubbles is the best here. I can no longer say any bubble. That reaction has ended. That means one of the reactant has reacted finish. Either all the zinc has reacted or all the hydrochloric acid has reacted. Did you get the point now?
Yes.
Good. Yeah. So when the logo, yeah, number 2. B.
B. Equation. Um.
That's
Equation
equation
for
for
the.
the reaction. Equation for the reaction. That's just this. Zinc. Zinc is always 2 plus. Behaves like a group 2 element. Is that okay? So zinc
Yeah.
plus HCl we give what? Zinc chloride and iodine. The way magnesium does. Zinc is always plus 2. Please bear that in mind. But it does not belong to group 2 element. It carries plus 2 all the time. And one, so we are you can write the equation for the reaction. Am I right? Yeah,
Yes,
C.
sir.
Reaction C. Can you read the question C? Can you read?
Calculate the rate of reaction with respect to hydrogen gas in cubic centimeters and zinc in
Zinc
moles
in
per
mole
second.
then hydrochloric acid in what? Mole per second. Is that okay?
Yes.
How do we know now? Now, what do we need to do here? We don't know how much hydrogen was produced. We don't know which of them is the limiting reactant. What will you do? Listen very well. Find the mole of zinc. Go and do mole equals to mass over molar mass. Find the mole of zinc. Is that okay?
Mm-hmm.
Then find the mole of hydrochloric acid. How do you find the mole of acid? Mole equals to concentration times volume over 1000. Am I right?
Yes.
Are you sure you remember that?
Yes, sir, I do.
Good. So find the mole. I think I don't know if I did it too, but I didn't do it. So find the mole of, are you listening to me? Find the mole of zinc. That will be 3.25 over what? 65. Mole of
Mm-hmm.
acid. That is 0.5 times 50 over 1000. Is that okay? Let us assume that the
Mm-hmm.
mole of zinc. Are you there? Let's say the mole of zinc is 0.012. And mole of acid is 0.02. So what will be the mole of hydrogen now? Let's say the mole of zinc you calculated was 0.012. Zinc mole of acid 0.020. What will be the mole of hydrogen produced and how do you get it? I'm waiting.
We use the ratio 1:1.
Tell me what is the mole of hydrogen? Tell me. Yeah, use yourself. Yeah, tell me the answer.
0.012.
Thank you. God bless you. 0.0 what?
12.
No, you're wrong. Now, to start with, yeah, Tamuda, which of them is in essence, zinc or HCl?
In the question,
Yeah, from the equation,
can
we've seen that the mole of zinc is 0. Let's say the mole of zinc is 0.012. Mole of HCl is 0.020. From those values I wrote on top of zinc and HCl, which of the reactants is in excess?
the HCl.
No, it's ratio 1:2 now. 2 mole of HCl, 1 mole of zinc. Tamunda, 2 mole of HCl should react with 1 mole of zinc. So when HCl is 0.02, zinc should be 0.01. Do you agree?
Mm.
So which one is in excess?
Zinc.
Thank you. Are you sure you understand that?
Yes, I understand.
Good. Acid is 0.02. Zinc should be 0.01 because it should 1:2. Do you agree? So for
Mm.
zinc to now be 0.012, that means zinc is in excess. Is that okay? So who determines the amount of hydrogen now? Is it acid or zinc?
The acid.
Thank you. What's the ratio between
Mm.
acid and hydrogen?
2:1.
So what would that be the amount of hydrogen produced now?
0.01.
Thank you, 0.01. That's it. It should be half of it. Are you sure you understand this thing I explained here? You
Yes, sir,
find
I
both of
understand.
them, you compare them. Look at the one
Mm.
that is limiting, look at the one that is in excess. That means this reaction, if these are the value you got, I didn't know, we didn't do it. I just you can do it and send my to check if you get it. Now, now this mole of zinc is in excess. So acid is the limiting reactant. Is that okay? So when you now get the mole of hydrogen, let's say mole of hydrogen will now be what 0.01. Then convert to volume. Now I'm going to use 0.01 mole equals to volume over 24,000 cm cube. Am I right? What's now
Yes.
your volume? Volume is what? 240 cm cube.
Mm.
We say mole of hydrogen is 0.01. We don't know the volume. Molar volume is 24,000. Volume should be this, which is 240 cm cube. Are you there? So that's
Yes.
what hydrogen produce. Now come back here. They now say, how long does it take? 3 minutes, 20 seconds. How many seconds is that? 200 seconds. Am I right? So
Yes,
the
it's
time taken is 200 seconds. And what is the volume of gas produced? 240 cm cube. Therefore, this one will now be 240 cm cube over 200 seconds. Are you there?
mm-hmm.
Get on. Is that correct?
Yes.
You now say find the mole with respect to calculate the rate of reaction with respect to zinc in mole per seconds. How many mole of zinc reacted?
0.01.
Thank you. Thank you. Not 1, 2, 0.01. Not all of it
Mm,
reacted. So it will now be what? 0.01 mole of zinc over 200 seconds. You get your answer again. Do you agree?
mm.
Are you sure you understand that?
Yes, sir.
Now say number 3. With respect to hydrochloric acid in mole per dmk per seconds. In terms of concentration, what is rate? Come and tell me here from here. What's rate?
Change in concentration over time.
So you have to know the initial concentration and the concentration of the acid after the action is completed. Then the change in both of them over time taken. Then come back here. What was the
Uh,
original concentration of the acid?
what is it? 0.5 mole per dm cube.
0. What?
0.5.
Now, if zinc is in excess, what would that be the final concentration of the acid? Suppose zinc is in excess. What would be the final concentration of the acid? Kamina, do you get my question?
Yes, but
Suppose what we wrote here, zinc is in excess. Acid concentration initially was 0.50. What would not be the final concentration of the acid? I'm asking you. It will be 0. How about the acid reacted? Because zinc was in excess. At the end, all
uh,
the acid reacted. I mean, at the end of the day, acid was 0 mole per dm cube. It's no longer there. All of it reacted. Do you agree?
mm,
Are you sure you'll get that?
yes, sir.
Acid was initially 0.5 mole per dm cube. If
Mm,
zinc was in excess, that means all the acid reacted. Because we allowed the reaction to complete. So
mm,
change concentration will now be 0.50 the initial minus 0, which is be
yeah,
0.50. The overtime taken. Do you get the point now?
yeah, I do.
That will be the change. That will be the with acid in this point. Now see, so your time taken for the reaction if HCl is replaced with ethylic acid. When we use HCl, it was 200 seconds. Am I right? Here will be what?
Mm,
Greater than 200 seconds. Is a weak acid. Do you get than 200 seconds? Are you getting it? It's a weak acid.
yes, sir. Mm,
This one, this one will be same time, same time. You see 200 seconds. This one will be less than, it will be like maybe like 100 seconds. Why? 1 mole H2SO4 contains 2
mm,
mole of acid, but 1 mole HCl is 1 mole acid. So when you say if you use HCl and H2SO4, same concentration, HCl will be twice as fast as, I mean, H2SO4 will be as twice as HCl. Do you agree in fast? You know why? The
mm,
concentration of H plus, I'm saying, what I'm saying is this. When you get it right, when you write X, okay, let me use specific value. Let me use 0.20 mole per dm cube H2SO4 actually contains 0.40 mole per dm cube HCl. Do you I mean H plus? Do you agree? For
yes.
every sulfuric acid, there are 2 mole of acid. Do you get?
Mm,
But 0.20 mole per dm cube HCl is still 0.20 mole per dm cube H plus. Is that only change? Do you get?
yes, sir.
So that means if they are the same concentration, sulfuric acid is twice as concentrated in terms of H plus than HCl. Do you get?
Mm,
You bear that in mind. So use sulfuric acid to be faster. Why? 1 mole of sulfuric acid contains 2 moles of acid. But HNO3 and HCl, they are the same thing. They are both strong acid. But reaction 1, why will it be slow? It's a weak acid. It does not undergo complete dissociation. So reaction will be slow compared to strong acid. Is that okay?
Yes, sir.
Now, what are the factors affecting rate of reaction?
Concentration. When concentration increases, number of particles per unit volume increase and particles become crowded closely together. Yes, I can.
Yeah, please, can you start reading?
Factors affecting rate of reaction. 1. Concentration. When concentration increases, number of particles per unit volume increase and particles become crowded closely together.
Interparticle, this one is interparticle distance. Interparticle distance. Yeah, go
Inter-
on.
Interparticle distances decrease and frequency of collisions increase, thus rate increases.
So why does an increase in concentration lead to an increase in rate? At high concentration, there are more particles per unit volume. The particles are now crowded together. They are very close. Am I right? So
Yes,
they
sir.
collide more frequently and rate increases. Is that okay? No story. Pressure effect.
Pressure. To increase pressure, decrease the volume of the reaction vessel at constant temperature. Increase the moles of gas at constant volume and constant temperature. Pressure
Mhm.
only affects rate of reaction involving gases.
Yeah.
Effect of pressure in gases is the same as that of concentration in solutions.
What I mean is that when you say high pressure, I mean
Mm,
high concentration, higher rate. So is pressure. Higher pressure, higher rate. At
okay.
high pressure, the particles are crowded together. They collide more frequently. Rate will increase. Is that okay?
Yes, sir.
Temperature.
Temperature. When temperature increases, particles acquire greater kinetic energy. Proportion of particles with energy less
Greater
than or
than
equal to,
or equal to EA. As energy argon also increases.
and frequency of effective collision increases.
And rate of reaction will increase. Three things you can say. Number one, they gain more kinetic energy. The molecules whose energy is greater than EA will increase. There will not be more effective collision and there will be higher rate of reaction. Is that okay?
Yes.
They acquire greater kinetic energy. Molecules with greater than EA will increase. The frequency of effective collision also increases. Is that okay?
Mm.
Catalyst.
A catalyst increases rate of reaction by lowering activation energy, whilst itself remains chemically unchanged at the end of the reaction. A
Good.
catalyst is not used up at the end of a reaction.
That means the mass of catalyst before and after should be the same thing. Do you get?
Yes.
Yeah. Now this one. Can you read?
Boltzmann distribution of molecular energy.
Let me go and draw it for
Proportion
you.
of molecules.
Hold on, please. Let me clean. That's really you can understand this. When you want to represent the energy of reacting molecules, all the molecules reacting, they don't all have the same amount of energy. All of them don't all have the same amount. Some have high, some have low, distributed about a mean matter. Look at it now. This is the energy of reacting particles. You can see like this, like this. Good. Some particles are here. B is here, C is here, D is here, E is here, F is here, G, H, I, J, K. Now pay attention. This is my activation energy line. Which of these
Mm.
molecules will react? Which of them will react? This is our activation energy line. And energy is
K-
increasing this way. Which of the so
Yes,
which
sir.
of these particles will react?
KHJI.
Thank you. They are the ones that have more than EA. Is that okay? This
Mm.
is now if you now that's fine. If you now use a catalyst, what do you think will happen? Catalyst, you bring the EA
That.
here, you bring it here, you take it backward. This now be EA
Mm.
catalyzed. EA catalyzed, EA with catalyst. Can you see now? Before, MST. Before, who was reacting when there was no catalyst? Only KHJI. Who is now reacting with the catalyst now? All of these guys now. It now. So of course, KHJI react without catalyst. Of course,
Mm.
catalyst will still react. Do you agree? But in
Yeah.
addition to them, MGST will also join them. Do you agree?
Mm.
Do you get the point now? Or
Yes,
now
sir.
that we're feeling it, hold on. OPRU. If I now use high temperature, look at high temperature. I use high temperature. Is that okay? Hold on. Let me do like this. Let me not say J8. Let me do shaded and unshaded portion. That I can understand it. This is EA. I mean, that is at low temperature. Low temperature. What about high temperature now? This is not be high temperature. Now, without catalyst, with catalyst. Now, let's call them portion A, B, C, D. This is EA uncatalyzed. This is EA what? Catalyzed. Who will react at low? This is low temperature. This is now high temperature. Who will react at low temperature uncatalyzed
Who reacts at low temperature?
and uncatalyzed?
D. Huh?
Only D.
Which?
Only
Mm.
D. Yeah. This is because this is EA uncatalyzed.
Okay.
And this is low temperature. They meet here. This is only D. What about low temperature catalyzed?
Low temperature catalyzed. A.
Low temperature catalyzed.
Oh, B. That's B.
B and D, not B. B and D.
Mm.
It was already reacting when there was no catalyst. Now you see react when there's catalyst. Now, do you agree?
Mm.
So low temperature uncatalyzed D, low
Mm.
temperature catalyzed now B and D. Do you agree?
Mm. Yeah.
What about high temperature uncatalyzed? Be careful.
High temperature and catalyzed C
High
and
temperature
D.
C and what? C and D. This is
Mm.
high temperature uncatalyzed in C and D. What about high
Mm.
temperature catalyzed? All of them.
All of them.
A, C, D. Do you get the point now? Now, why
Yes.
was there an increase in temperature why was there an increase in rate when temperature increased from the graph? Can you tell me?
Why was
Why
there
was
a
there an increase in rate of reaction when you increase temperature? When you increase temperature, now let's now clean all this APC. Let's remove
okay.
catalyst now. We are using catalyst now. Or why was there an increase when you use catalyst? Catalyst moves back. Catalyst, I mean, it moves the EA line backward. Therefore, the proportion of molecules whose energy is now greater than EA will increase. Am I right?
Mm.
And therefore rate increases. Temperature also, what does it do? Look at temperature. This is the one that reacts without, I mean, at low temperature, this is the one that reacts. When high temperature with this guy joined them. Can you now see that? What can we say? We can say that at high temperature, though the EA line does not move, am I right?
Mm.
But the molecules, we said this is the maximum of the curve, the maximum. In this case, yeah, the maximum moves to the right. This is the maximum of the curve. It moves to the right. Am I right?
Yes.
And it goes low. It goes lower, making more molecules cross EA line. Do you agree?
Mm.
But this guy before, they are behind the EA line. They are not crossing before. At high temperature now, they begin to cross the EA line. Do you agree to that? So when
Yes.
temperature increases, the maximum of the curve moves down and moves to the right. Therefore, more molecules cross the EA line. So there'll be more effective collision and faster rate of reaction. Do you agree?
Mm.
Good. So this is it. So you can you read this. One year they said describe the curve. How do you describe the curve? Yeah, read it, please. Describe the
The dis-
Boltzmann molecular energy. Go on.
The distribution of energy among the reacting particles is not symmetrical.
What does that
The
mean? Not of them they don't all have the same energy. Some have low, some have high. Is that okay?
yes,
You are go on.
the most probable energy is the energy with the highest proportion of molecules, highest frequency.
Stop there. Yeah, I'm drawing only one of them so that you understand it. What's the most probable energy? Energy with the highest frequency. Where is frequency? This frequency here. Am I right? This frequency. Am I right?
Mhm.
So treat like this. This is the most probable. So you can call it E1. E1 is the what? The most probable energy. What about F1? Frequency of the most probable energy. Do you agree? The most
Yes,
probable energy is energy with the highest frequency. Is that okay? Or highest
yes,
proportion of molecules. Is that okay? Go on,
yes,
please.
A lot, and you're like, okay, do you have a private tuition? Don't you have? Do you have? And yes, Agile Tech do have a private tuition. So by my right, you can see that we have for the EdExcel and Cambridge IGCSE, and yes, we do have for all subjects. Okay, all subjects. Okay, the popular ones that's always been in demand is mathematics, English language as a second language. Okay, we have physics, we have biology, we have chemistry, and we have um, you know the flagship, which is ICT, just here and there. We also have business studies. So if you're interested for a private tuition, um, I think all you have to do is send an email to the sales team at agiletech@gmail.com, and they would reply to you, talk about your time zone, talk about, and the fee is really quite affordable. Really, it's really quite affordable. It's when you look at it across other tutoring service, I think this is the one that's quite affordable, and you get the very best of service. We also have for the E levels as well, um, and also for the EdExcel. So we have for the Cambridge E levels and EdExcel E levels. Okay, and we have also across the subject mathematics, which is usually the hot cake when it comes to E level, mathematics and chemistry, and then biology. These are usually one of the ones we have in demand always, all the time. Even physics, for E level. So all you have to do, if you're watching this right now and you are interested for a private tuition, then you can do yourself a solid, okay, and send an email to the sales team at agile@gmail.com, and they'll reply to you. And the good news about this is what I've discussed with the sales team is we've tried as much as possible to see how we can subsidize the amount according to countries, so it doesn't really look very heavy. Okay, so this is really important. Yes, we do charge in pounds, but again, we try to be as much as possible considerate to your countries, and we don't just skyrocket the price. No, because at the end of the day, we know how it feels, and we really want you to actually get the best of service, and again, be able to afford it from the comfort of your home. So again, Agile Tech private tuition is currently ongoing. You can enroll yourself for the IGCSE, and then for the E levels. Again, for the IGCSEs, these are the subjects, and for the E levels, these are also the subjects. So again, what are you waiting for? Just send an email to the sales team. If you're an IGCSE student preparing for IGCSE, if you're watching this in 2025, when this in 2026, when this is 2027, we're currently ongoing, and this is actually a good time for you to actually explore, and then get it tailored to your own needs. So trust me, you don't want to miss out.
When temperature increases, the magnitude of the most probable energy increases, but its
Eh,
frequency decreases.
let's do it. Increase temperature. How the graph go like this now, Abi?
Mhm.
Look at the most probable energy here now. Am I right? the value will increase. E2 is greater than E1. Am I right?
Mm.
But the frequency will decrease because F2, if frequency is increasing upward. Am I right? F2 is higher than F1. Is that not so?
Yes.
The frequency is increasing upward, right? So we
Mm.
have F2 here. Of course, E2 is greater than because energy is increasing this way, right? So
Mm.
when you increase temperature, what will happen to the most probable energy? This magnitude will increase. You agree from E1 to E2, right? But its
Mm.
frequency will decrease from F1 to F2. Do you agree?
Yes.
Good, thank you. We are going.
When temperature increases, molecules acquire greater kinetic energy, and proportion of molecules with energy greater or equal to activation increases.
That is, go on.
That is, proportion of molecules on the right side of activation energy line increases.
Mhm. Go
Frequency
on.
of effective collision increase and rate increase.
Thank you.
A
We are
change in temperature,
has no effect on the what?
activation energy line.
Thank you. Do you get now? When they said this EA line now said show the position of the EA line and label it at H at high temperature. What will you do? They said show the position of the EA line and label it as H. Just do like this. Same place. They said show the position of the word EA line at just do like this. Same place and label it as H. I mean it doesn't change. Do you get?
Yes.
Temperature does not affect EA line. Only catalyst does. Is that okay?
Mhm.
What next again? Yeah.
A change when a
Good.
catalyst is used, activation energy line moves to the left and percentage of molecules to the right side of activation energy increases. Increases frequency of effective collision increases. Hmm? Frequency of effective collisions increase and the rate of reaction increases.
I'm sure that makes sense also. Last part of the
Mhm.
topic. Yeah, let's read. Yeah.
Homogeneous and heterogeneous catalyst.
Catalysis.
Catalysis. A
Yeah.
catalyst increases rate by providing an alternative mechanism or pathway with a lower activation energy.
Thank you. Yeah. So look at all this. You understand them. EA1, EA2. I put how many EA there? EA. Yeah, look at them one by one. Look what's EA1. Where's EA1? EA1 is what? EA1 is the EA of the uncatalyzed reaction in the forward sense. Is that okay?
Mm,
EA line is the what? Is the EA of what? Uncatalyzed reaction in the forward sense. What would that be the EA of that same reaction backward reaction? It will be EA4. Do you agree?
mm.
Are you sure you understand that? EA1 and EA4. EA1 is forward, EA4 is backward for uncatalyzed. Is that correct?
I'm not understanding
EA1
this
is,
diagram.
do you understand it? Do you understand?
Mm, no.
Now, I'm done with this. Let me open a new page for you. Yeah, just hold on.
Mm,
Show me the four reaction. This is the four reaction uncatalyzed. This one, am I right?
yes.
What's the EA forward? Now this is EA forward, uncatalyzed.
Mm,
EA forward, that's the length, this length now. Do you agree? I just drew it, I didn't draw it under the line. Is that okay? Is that not EA line?
yes.
This EA for the four reaction uncatalyzed.
Mm,
Whereby now, what's your reactant say? R. Your product P. Can you now consider P as your reactant now for the backward reaction now? What would that be
mm,
the EA line? This will be the EA. Look at the EA here. Do you get? Is it not so?
mm,
So
yes.
EA1 is the EA forward, uncatalyzed.
Mm-hmm.
EA4 is the EA backward uncatalyzed. Do you agree?
Yes.
Now, which one is the catalyzed one now? The blue one. Yeah, the blue is the catalyzed.
Mm-hmm.
What's
That's
now EA? What's EA for the catalyzed reaction, forward reaction?
EA2.
Now you are talking. What about the backward reaction catalyze?
EA3.
Now you are talking. What about enthalpy change for all of them?
Enthalpy
For all
there.
of them, same enthalpy change. Now, the enthalpy change for the forward reaction, no, that's not true. Enthalpy change for the word, for the forward, whether catalyzed or uncatalyzed. Do you agree to that?
Yes.
Once now the enthalpy change for the backward reaction, it should be like this. It should come down. Down is endothermic. Yeah, okay, coming down.
Okay.
This
Yes.
do you agree to the same value but opposite sign? Do you agree? For the forward, this is enthalpy change for the forward reaction. That is endothermic. Is that not endothermic? It's going up. For the backward, same value, but this time exo.
So it's going
If
to be
A
negative.
exactly, if A to B, enthalpy change is plus 50. B to A, it should not be minus 50. Do you agree?
Yes.
Good. That's what I just told today.
Okay.
Good. Yeah, now look at this again now. Now, I'm not sure I leave with this. Yeah, let's go. This is a multi-step reaction. Pay attention. Oh. Multi-step reaction. Catalyzed and uncatalyzed. The black one is catalyzed. Are you there?
Okay.
The red
The
one is
catalytic one
the
is
black one
red.
is uncatalyzed. The black one is uncatalyzed. The red one is catalyzed. Are you there?
Yes.
R is reactant. I is intermediate. P is product. I'm not sure. Did I define them? I think I defined them. Yeah, I didn't define them. Oh my God. Will you remember them? I have written them for you, and I've sent the note to you already.
Okay.
R is what?
The reactant
What about P?
product
What about I?
intermediate. You said
I is
intermediate?
intermediate. When you like now, when you combine sperm and ovum together, before a child is produced, what is intermediate? What is first intermediate? Zygote.
Zygote.
You get now. When I become later fetus, or whatever, before it now become a baby, like finally, is that okay?
Oh,
Intermediate is
okay.
what was formed between reactant and product. It's not
Okay.
the reactant, it's not the product.
Mm.
Sometimes it doesn't look like any of them. It's a complete thing entirely. It's different complete from both of them. Is that okay? Sometimes
Mm-hmm.
it's like a mixture of both of them. Is that okay? But the intermediate is
Okay.
what? A substance that is formed from the product, from the reactant before the product, when it finally become product. Do you get the point now?
Yes, I
So
do.
I is intermediate. So R is reactant, P is product, I is intermediate. The black line is the uncatalyzed reaction. The red line is the catalyzed reaction. The positions of R, I, and P are never affected by catalysts. Catalysts only make it to go from R to I faster, I to P faster. The position where they are, as in where they are now, R is always here. I is always here. In this case, P is always doesn't change. Is that okay?
Mm.
Do you get? Now let's go. What? So let's consider the uncatalyzed reaction now. First of all, hey, you can know what be. Let's consider the uncatalyzed reaction, the black line. What is the
Okay.
EA for the first step? There
That's
are two
two.
steps now for the uncatalyzed now. There are two steps for the uncatalyzed reaction. There are two steps.
Mm.
What's EA for the first step? EA1 for the uncatalyzed. I label them, tell me the value there. Tell me the value there. What is the EA1 for the uncatalyzed? There are two EA. Catalyzed has two EA. Uncatalyzed has two EA. What is A? Should I go wait? Go wait for me outside. You go make class here. You go me.
Two.
Two. Thank you. How about for the second step? EA for the second step. Uncatalyzed. Be careful.
That's that's going to be three.
Should be what?
Three.
You are going from intermediate now. That's on three. Can be three. Now from R to I, two is
Mm.
the EA. Now from I to P. Now what's the EA? Look at it very well. I'm not telling you. From
Okay,
R to
from I
I,
to
R to I, EA is two. Am I right? Now, what about I to P now? That's the second step. What's EA?
I to P is seven.
What is it? 7.
Yes.
the energy barrier that must be overcome from I going to P. You are starting from I now. Tamuda, you are starting
Okay.
from I now. You want to overcome a barrier to go to P.
5.
Hey, now you are talking 5. Just overcome the barrier. Then you overcome the barrier, jump down straight away. Do you get? Are you sure you understand
Oh,
that? So
oh,
R to
yes.
I,
Yes.
EA1 is 2.
Mm,
I to P now, EA2 is what? Is 5. Is that okay?
mm,
That is for uncatalyzed forward. Now let's now do uncatalyzed backward now. Backward reaction now.
mhm.
What is EA1 backward for the uncatalyzed? Now you are going from P to I now. Am I right?
Yes, so that would be 7.
Now you are talking. Now what about
Yes.
uncatalyzed backward EA2?
That would be from I to R.
Yeah.
That's 3.
Now you are talking. So you are done with that now, right? Now let's go
Mm,
now. Now, now let's go now. What about catalyzed now? Catalyzed. EA1 catalyzed for the forward.
that's 1.
Now you are
Is
talking.
it 1?
EA catalyzed.
Then
EA2 catalyzed.
that's 6.
That's 6. Now you are talking. Now
Mm,
again, EA catalyzed backward. You are going backward now from R to I now. For the first step, backward now. For the first step. First step is
mm.
now P to I, backward. We are
8.
catalyzed P to I. That'll be what?
That's 8
Now you are talking. Now, what about second step now? You are going from I to what? I
to
to R.
that's 4.
Now you are
Yeah.
talking.
4.
Now, what's the enthalpy change for the whole reaction? For the whole reaction, what's the enthalpy change for the whole reaction?
10.
What?
10.
No, for the whole reaction, you see R and P. Ignore the intermediate, also be there with intermediate. For the whole reaction, for the entire reaction,
Oh,
reactant product
I mean
is 1.
11.
Is that 11 or 1? Okay, is it what? Oh, it's 11. Yeah, it's 11. You're right. It's
11.
11. From the enthalpy for the whole reaction is 11. Now, what about what's the energy? What's the, for stage 1 uncatalyzed? Stage 1, either catalyzed or uncatalyzed. What's the enthalpy change for stage 1? That is R to I. Whether catalyzed or not, it don't affect it. Is what? Is 9. Do you agree?
Mm,
To go from R to I, the energy change is 9. Do you agree?
yes.
So now go from I to P. What's the energy change?
10.
Now you are talking. What's that the overall energy change? 10 is more than 9. Do you agree?
Mm,
10 is like, let's say 10. Are you listening to me? Let's say 10 is minus 200. It's coming down. 9 is
mm,
plus 160. All this can now be minus 40. Do you agree?
mm,
The energy gained to go from R to I was 160. Now the
mm,
energy lost to go from I to P is now minus 200. Is that okay? So at the end of the day, the
mm,
guy has lost. How much has he lost? Only 40. Do you get?
mm-hmm.
Are you sure you
Yes.
understand what now?
Yes.
So you need to go over them again. I thought I defined all of them. I didn't define them. It takes time.
Okay.
But at least you have to do it together. I think it makes sense. If you just go over it again, I think you understand. Is that okay? You need to go over it again now. You
Yes,
have
sir.
understood it.
Yes, sir.
Good, that's fine. So that's what the cell should learn. So it is a multi-step reaction. It involves many steps more than now. Sometimes it can be like this also. Look at this one. For the for
Mm,
the, for the, for this one, we don't just consider now. Both the catalyzed and non-catalyzed involve an intermediate. Do you agree? And
mm-hmm.
what's the intermediate? I. Both the
Mm,
catalyzed and non-catalyzed involves an intermediate, which is what? Which is I. Do you agree to that?
yes.
But for this one now, the uncatalyzed guy does not involve any intermediate. Only the catalyzed does. Are you getting it now? Uncatalyzed here, now the black one, it does
Mm,
not involve any intermediate.
only
Only the
catalyzed.
catalyzed does. Do you agree?
Yes.
I think that makes sense. So that's what the section like there. Yeah. Can you read?
When a catalyst exists in the same place as the
It's the
reacting
same
substance.
phase. In the same phase. Phase is like state, but not really state. Now let me explain to you. Water and kerosene, are they in the same state? What
Sorry?
do you know kerosene?
No.
You don't know kerosene. Okay, do you know groundnut oil?
No.
Vegetable oil in call.
Vegetable?
Vegetable oil, vegetable oil.
Yes.
Do you know vegetable oil?
Yes.
Now, vegetable oil and water, are they in the same state?
No.
Hey,
Liquid, yeah.
vegetable oil and water, are they in the same state or not?
They are.
Now, vegetable oil and water, are they in the same state or not? They are both liquid.
They are.
But are they in the same phase? Will they mix together?
No. They
Hey.
won't.
So, so vegetable oil and water are in the same state, but in different phases. Phases means for them to be in the same phase, they must be in the same state in the first place. I'll say that again. For them to be in the same phase, they must first for be in the same state.
Okay.
Do you get the point now? For them to be in
Yeah.
the same phase, they must first for be in the same state and be able to mix with each other as same phase. They're in the same state and they are able to mix together with each other. That will call phase. Is that okay? So, what is homogeneous catalysis? In homogeneous catalysis, the catalyst and the reacting substances are in the same phase. What about heterogeneous catalyst? In heterogeneous, look at it. Heterogeneous catalyst,
Different.
reacting substances are in different phases. Homogeneous catalyst and the reacting substances are in the same phase. Is that okay? Do you get the point now?
Yes.
Homo means not like homozygous now in biology. Homozygous. Homo means similar in this context. Homozygous, heterozygous. Is that okay? Heterozygous allele, homozygous allele. Is that okay?
Mm.
Yes.
Mm.
Okay. Do you get the point now?
Yes.
That's how that's the end of that topic. It's almost so we are
Okay.
done with it now. I posted the note. I posted the past question for you to also solve alongside. Is that
Okay.
okay? So please go
Yes.
over the notes, go over the question. Let me know the one you don't understand. We are doing enthalpy change, chapter 5.
Okay.
Then next we also do redox. We do enthalpy change, chapter 5, redox, chapter 6. We have done chapter 7 and 8 already. So after next week, we are done with physical chemistry. We go to inorganic. Then go to organic. Is that okay? So
Yes.
if you finish physical chemistry end of next week, is that okay?
Thank
So
you.
thank you so much. I posted the note already, so you can just download the note and go over it.
Okay, sir.
Thank you so much.
Thank you.
Yeah. Bye bye.
Bye.
Yeah.